So you got an elevator, got a person standing in the elevator. You've got a force of gravity down on them. You've got a normal force up on them. And then it tells you it's accelerating at a rate of 1.4. So it tells you there's an acceleration downward of 1.4. Okay. So here's what most people did. What most people did is they found the net force using F net equals ma, is exactly what you want to do to start with. So the mass was 61 times A, which was 1.4. Was it 85.4? Good. All right, and a lot of people stopped there. So that's not what I'm asking for. I'm not asking for the net force. I'm asking for the normal force. So if you got this answer, you didn't go far enough. A lot of people also did this. They found the force of gravity by doing mg, 61 times 9.8. What is it, 597.8? Thank you. And stop there. And the reason they did this is because we've always done problems where the normal force equals the force of gravity. And that's true if there's no acceleration, but there is an acceleration. So that doesn't work in this case. So this is not the answer. 597.8, that's not the answer. 85.4 is not the answer. What you need to do is find the missing force. And it's very, very similar to what we did in one of our other examples. In the notes that we were working on. Let's see if I can find it quick enough. I don't have notes 3 handy. There we go. It's very similar to this sort of a problem, where I gave you the acceleration, you use that to find the net force, and then you use the known force to find the missing force. That's the same thing we're doing here. I'm giving you the acceleration. You can use that to find the net force. And then you use the known force, which is gravity, to find the missing force, which is normal. And the equation you use for that is F net equals F1 plus F2 plus whatever. So you would set that up as F net 85.4 equals F1 597.8 plus F2, which is Fn. Now, these should both be the same direction. They can either both be negative or both be positive. Most people called it positive because it's the forward direction is down. And we've been calling forward as positive, so down would be positive. Some of you made it negative because you just like down to be negative, and that's totally fine. But they should both be negative then. So you get 85.4 and 57.8. So you subtract that, and you get like 512 point something. 512.4. So you subtract the 597.8 to both sides. And you get the normal force to be negative 512. And yes, it can be negative. So just be careful on this problem. I know it's tricky because it's vertical instead of horizontal, and that threw people off. But just be careful when you're setting things up, how you're solving it and how you're plugging your numbers in and where you're going from there. Okay? Any other questions on practice 3?